Hey guys, it's me, Miss Miller, here to teach you about the unit circle. I am so excited to teach this lesson and I wish it was in person, but let's just get started. To first start off, let's define what a unit circle is. Just like in geometry and in your earlier years, a unit of measure is normally 1. So if we talk about a unit circle, we're talking about a circle formed with a radius of 1 and it's centered at the origin. And any angle that's formed within the unit circle is going to be in standard position where the initial side is on the positive x-axis and the terminal side for a positive angle that's formed is going to go counterclockwise, and where it lands on the unit circle is what we're going to be talking about today. So here's an example of what a unit circle looks like if you were asked to draw one. You would start it at the center at 0, 0, and then you're going to travel around using a radius of 1. And these, I don't want to say endpoints because circles don't have endpoints, they're infinite points, but if you look at these, each of these represent the quadrant that you're working in. These are your quadrantal angles. So if we talk about this more, this would be your 0 degrees or 0 radians. The angle formed with an initial side on the positive x-axis and a terminal side on the positive y-axis would then form 90 degrees. And that would be 90 degrees, also known as pi over 2 radians. The reason it's pi over 2 is because if we were to travel 180 degrees, where your radius is 1, so it would be negative 1, 0 because we're on the negative x-axis, we'd have pi radians. And if you were to travel to your negative y-axis, we're talking about 270 degrees, also known as 3 pi over 2 radians. And if you were to make a full rotation, I know this is getting a little messy, you would have 360 degrees, also known as 2 pi radians. And it's important to start just thinking of this as your basic model as we go into finding more angles in the unit circle. In our last section, we talked about any point in the coordinate plane forming trig functions. So the example of that is right here, where we have our radius to the point from the center, the x distance you travel, and the y distance. So the x distance is horizontal, the y distance is vertical, giving you that point P. And the trig functions that are then formed for the angle on the interior of that side would be y over r for sine, x over r for cosine, y over x for tan, r over y for cosecant, r over x for secant, and x over y for cotangent. Those 3 functions are the reciprocal identities of the first 3 functions, sine, cosine, and tangent, and vice versa. The thing that's different is now that we're working in the unit circle, we no longer need this because we know what r is. R in the unit circle is always 1. So how does that change our look at all of these functions? So if we were to look at the sine of theta equaling y over r, and r is now 1, we could say that sine is just y. So let's take a look at that deeper. When we define trig functions in the unit circle, this is not replacing what you learned previously, but rather adding on to it. If you have an angle that's a real number, whether it's in degrees or radians, and there's a point on the unit circle, where again the radius is 1, we can now say the trig functions of the angle formed in the unit circle is just that sine of theta, whatever angle you have, is equal to the y value of that point. Cosine is x. Tangent is y over x. That still has not changed. I did put a note here, x cannot be 0, as we know, but I want you to just look at those first 3 and think about your quotient identity. The first quotient identity I introduced to you back in 5.1 or 5.2 was tangent of theta equals sine over cosine. And this is really fascinating because if you think about it, sine over cosine, in this instance, our sine is the y and cosine is x, which is the same property that we learned earlier. Tangent of theta is y over x for any point. So they all are interconnected. Cosecant is now 1 over y because it's the reciprocal identity, also because it's r over y, and r is now 1. Secant of theta is now 1 over x, again because it's the reciprocal identity of cosine, and also because r is 1. And cotangent, because of the reciprocal identity, will be x over y. Also, our quotient identity for cotangent is cosine over sine, which is x over y when we're talking about cotangent. So when we look now at a unit circle, our radius again is 1, any angle that is formed, but now the point, instead of x and y, we can now relate them as cosine and sine. Before we look at other angles besides 0, 90, 180, 270, 360, let's look at our special right triangles. You've become very familiar with these angles over the past couple of days and weeks, but this triangle represents a radius of 2. How can we now make it that it would be a radius of 1? How can I make this radius of 2 become a radius of 1 in a unit circle? So again, if you want to kind of think of it as here is your, I'm trying guys, coordinate plane. Okay, here's the circle formed to the best of my drawing abilities. Here's the point. So my radius is 1, and I have 60 degrees that's formed right here. How can I relate these two things? Well, if I divide everything by 2, almost like a scale factor, I now have a radius of 1 because 2 over 2 is 1. And now the vertical distance traveled is root 3 over 2. And the horizontal distance traveled is 1/2. Using what I already know, that cosine is the x value, right, of 6. So my x value is 1/2, and my y value is root 3 over 2. The same can be done for our 45, 45, 90 triangle. Here, my radius is the square root of 2. If I want to make that 1, I'm going to divide everything by the root 2. Root 2. And when I do that, I now have a radius of 1. And now my x and y, which will be the same values, will be the square root of 2 over 2. I just rationalized the denominator, and root 2 over 2 again. So that point that's formed from the center here, this would be in our second quadrant, we'd have root 2 over 2, root 2 over 2 for our x and y values, which again would represent our cosine and sine values for 45 degrees. When you look at it inside the unit circle, you can see here is the opposite of what we have. But here's a triangle that's formed with the radius, the x horizontal distance traveled is root 3 over 2. The vertical distance traveled is 1/2, giving us that point root 3 over 2 and 1/2. This would be the cosine of 30 degrees and the sine of 30 degrees. We will never write our values as 1 over root 2, but rather root 2 over 2 and root 2 over 2. But you can kind of see now where 45 degrees would be in our unit circle. And there's, as we talked about reference angles before, these all get rotated around throughout our unit circle. So here's our first quadrant, and this is very important to kind of have down. And we can first look at our quadrantal angle at 0 degrees and 90 degrees. This makes a lot of sense because our radius is 1. And then all of these, as my x value decreases, going from root 1 to root 3 over 2, root 2 over 2, 1 over 2 to 0, we notice that our cosine is decreasing as sine is increasing. And by the end of this unit, you're going to want to have this memorized, and you might think that this is pretty daunting, but I want to kind of show you a trick. If we look at this point, 1, 0, you can rewrite 1 to be the square root of 4 over 2. And you might be thinking, how the heck are you getting this number? And I'll explain a little bit in a minute. But if we take a look, the square root of 4 over 2 is 1. The square root of 4 is 2 over 2, which does give us 1. And we look at our x values. And if you look, x is the horizontal distance, which is decreasing as we go from each point. It's getting closer and closer to the y-axis. And notice it's a countdown. Square root of 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, which is just 1, and 0. The same can be done for your sine values. You start at 0 because it's on the x-axis, and we're going to increase 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, which is just 1. And that will kind of help you to memorize the direction of things and how things are forming. As we go closer and closer to the y-axis, your y values are increasing. A lot of you made that note in your introduction sheet that you noticed in the first quadrant that your cosine values were decreasing as sine increased. And we'll take a look as we go further. So to take a look at just all the angles in the unit circle, there's infinite angles, obviously, but we really specify the quadrantals and our 30, 60, 90, 60, 45, and quadrantal angles as we go forward. So let's first look at just the quadrants. So in degrees, this would be 0 degrees. This right here, our positive y-axis would be 90 degrees, 180, 270, and you can also add here that this would be 360. So this, we really kind of counted by 90s if you think about it. 0, 90, 180, 270, 360. And now let's take a look at our 45-degree triangles, kind of cutting everything into fourths, right? So it would be a fourth of a pi, but let's take a look. So this would be 45 degrees. If I add 45 degrees, I get 90, which is good. It should be there. Add another 45. And we get 135. Add 45, I get 180. Add 45, you get 225. Add 45, you get 270. Add 45 to 270, you get 315. 315 plus 45 is 360. So as you can see here, it's not so much memorizing all these angles and degree measures, but just counting. Knowing the first quadrant is crucial. Last but not least, let's look at our 30 and 60 degrees. Now 30 and 60 are complementary angles in that special triangle, so we're going to do them together. So let's first look at 30 degrees. If we add 30 and going all the way around our circle, 30 degrees plus another 30 is going to give us 60. Plus another 30 is 90. This is how you know you're kind of counting correctly. 90 plus 30 is 120. Notice that 120 has a reference angle of 60 degrees. It's 60 degrees away from 180. You can kind of take a look at it that way. 60 plus 60 plus 60 would give us 180 if we weren't counting by 30s. Adding 30 to 120, and we get 150. Again, the difference between 150 and 180 is 30 degrees. That would be my reference angle. 30 plus 150 is 180. 180 plus 30 is going to give us 210. Again, the difference here is 30 degrees. Add another 30 to 210 and we get 240. Again, the reference angle from your horizontal axis to this angle would be 240 would be 60 degrees. Add 30 degrees to 240, you get 270. Plus 30 is 300. The difference to your horizontal axis would be 60 degrees. Adding 30 more, we get 330 to 360 is 30-degree reference angle. So these are all the angles within your unit circle. I hope the way we counted it together helped you, I highly recommend that you try to draw this on your own and create your own degrees as you go through this. But now we're going to take a look at radians. If you'd like to pause the video here to kind of reabsorb or rewind, that's fine, but we're going to move on to our radians. So again, we're going to first look at our quadrantal angles. We know that 1 radian is the arc length of 1 using 1 as your radius, but we're going to talk about each of these angle measures in radians. So again, you're going to start with 0 radians. And if we take a look, to get to here, we're going to have pi over 2 radians because that's 90 degrees, or half of pi. Going 1 full 180 degrees is pi radians, 3 pi over 2, and then back to 0, which is a full rotation of 2 pi radians. We're going to count just like we did before. So when we look at a 45, 45, 90, we know 45 degrees is pi over 4 because it is a fourth of pi. It's not a fourth of the circle. It's actually an eighth of the circle, but it's an eighth of 2 pi, or 1/4 pi. So let's count by fourths. Pi over 4. 2 pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4. 4 pi over 4 is just pi. 5 pi over 4. 6 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over, 7 pi over 2. 4. And then 8 pi over 4, which would give us 2. So again, if you know how to count by just the first quadrant, you'll get all of your radian values. So again, I like to count by our 30 degrees. So 30 degrees is pi over 6. Pi over 6, so 1/6, 2/6. 2/6 reduces to pi over 3. Adding up, so 3 pi over 6 is 1/2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. 6 pi over 6 is just pi. 7 pi over 6. 8 pi over 6, which we reduce to 4 pi over 3. 9 pi over 6, which is 3 over 2 pi. 10 pi over 6, which reduces to 5 pi over 3. And 11 pi over 6. And then 12 pi over 6, which is 2 pi. Again, just knowing how to count from your first quadrant is going to help you with all of these values. So this is your unit circle in degrees and in radians. Now let's take a look at what these points, each of these exact points are. These are special points on our unit circle. So I attached this worksheet for you to fill in. It's a little bit different than what I was able to put together, but as you can see here, I want you to fill in, take the time to fill in what your degree and your radians. So this would be 0 degrees or 0 radians, 360 degrees, 2 pi radians, that's what both of the lines are here for, 90 degrees, pi over 2, 180 degrees, and pi radians. You can see how you can fill this out. So I'd like you to take the time and fill out based on what we did. If you need to rewind the video or count for yourself to make sure that you have all the correct angle and degree measures, you can type that right into your Google Doc, or you can print it out or just draw your own. That's fine too, just so that you have it as your own reference tool. This I typed up a little bit so it was easier for me to go over with you guys. If we look at back the unit circle, we know we have a radius of 1. Here's all our angle measures that we have. I'm again going to start with just our reference angles, our quadrantal angles, I'm sorry. So at 0 degrees, we have the point 1, 0. At 90 degrees, we have the point 0, 1. Notice in quadrant 1, both x and y are negative. Remember, this is all functions are positive. Students are sine and cosecant functions are positive here because our y is positive. Here, tangent, all students take, our x is negative and so is y. So I'll keep writing tangent and cotangent are positive here, and then in the fourth quadrant, our x is positive but y is negative, and that's why cosine and secant are positive. So as we go, for 180 degrees, or pi radians, you're looking at the point -1, 0. And for the point of 270 degrees, or 3 pi over 2, we have the point 0, -1, which we talked about at the very beginning of this video. Now, as we go ahead and make the rest of these points, let's again look just at pi over 4. The triangle that's formed at 45 degrees, we know to be √2/2, √2/2. So that is going to be our point, √2/2, √2/2. If we look again where there's a reference angle of 45 degrees, or pi over 4, this is -√2/2, positive √2/2. You can kind of see that. So my value would be -√2/2, positive √2/2. Again, if I drop it to my horizontal, my reference angle is 45 degrees. My x has traveled -√2/2 units, and this is -√2/2 units to give us the point -√2/2, -√2/2. The reason tangent is positive here because negative y over negative x is going to give you a positive. Same with cotangent. Negative x over negative y would give you a positive. Last but not least, a 45-degree reference angle from 315 is going to give us a positive x value of √2/2, and this will be -√2/2. So notice any of the angles that form a reference angle of 45 degrees, or as I think a couple of you noticed, that if the denominator in radians is 4, that the reference angle is pi over 4, giving you that value √2/2, √2/2, and just knowing what the signs have to be. I'm going to erase my work here so that we can continue to make the entire unit circle. All right, looking at our next value, we're going to look at 30 degrees. And instead of counting by 30s, we're just going to look at 30-degree triangle. As we saw in our special area triangles, the horizontal distance traveled would be √3/2. The vertical distance traveled would be 1/2. This again is a reference angle of 30, or pi over 6. The other side that has 30 degrees, it's almost like a reflection, not like a reflection, it is a reflection. Our reference angle of 30 of 150 degrees, but now we're going to have a negative x value, so -√3/2 and 1/2. 210 has a reference angle of 30 degrees. Notice that all of these have a common denominator, pi over 6, 5 pi over 6, 7 pi over 6. All of them have a reference angle of pi over 6 because they're 30 degrees. Here I'll have -√3/2, -1/2. And finally, 30 degrees also has a reference angle of 30 degrees, and that is going to give us the point in positive √3/2 and -1/2. So again, like I said before, as long as you know your first quadrant, you just need to know where your angles are to know the value of the signs. And last but not least, let's look at 60 degrees, or pi over 3 radians, which is related because they are complementary. 30 degrees and 60 degrees are complementary angles, and sine and cosine are cofunctions. So what ends up happening is these points end up inverting, so it becomes an x value of 1/2 and a y value of √3/2. 120 degrees has the reference angle of 60. It's 60 degrees away from 180, but is now in the second quadrant. So our sine is now going to be positive and cosine is going to be negative. So we have negative 1/2 root 3 over 2. In the third quadrant, for 240 degrees, or 4 pi over 3, we're going to have negative 1/2 and negative root 3 over 2. And in the fourth quadrant, your y value will now be negative and x will be positive for 1/2 and negative root 3 over 2. I know this is a lot to take in, but the whole reason we're doing this is to make evaluating a lot quicker. So, with that being said, how to use the unit circle. If I'm asked to find the cosine of 7 pi over 6, all I have to do is, if I have my unit circle in front of me, I can reference it to say 7 pi over 6 is right here. My cosine, I always know my point is cosine of my angle, sine of my angle for each point. For 7 pi over 6, I was asked the cosine, which is my x value, so it is negative root 3 over 2. If you want to just use your first quadrant, knowing that the reference angle is pi over 6, and that this is in quadrant 3, we know it's negative, so we just have negative root 3 over 2 as our answer. All right, secant of 3 pi over 4. We know secant of 3 pi over 4 is the same as saying 1 over the cosine of 3 pi over 4. So again, find what your cosine of 3 pi over 4 is. 3 pi over 4. My cosine is negative root 2 over 2. Again, reference angles would work here too if you wanted to just memorize your first quadrant, but then we want to simplify this, so we get negative root 2. All right, tangent of 3 pi over 2. This is special because it's a quadrantal angle. Tangent we know to be y over x. 3 pi over 2 is the point, 0, negative 1. So I have negative 1 over 0. Unfortunately, because x is 0, this is going to be undefined. I'll just put the points here, even though I went back and referenced it. This was the point, negative root 3 over 2, negative 1/2. And to use 3 pi over 4 was negative root 2 over 2, root 2 over 2. Your sine, again, is that quadrantal angle. Pi is at negative 1, 0. Sine is your y value, so this is going to be 0. So without having to memorize the triangles, if you have your unit circle memorized, if you know at least just the first quadrant, it can be helpful to identifying what your reference angle and then what quadrant you're in to then solve. I hope this is helpful, and I hope everyone is doing great.